Welcome to College Algebra. This is section 4.4. We are looking at application problems that involve ratios. So here at a construction site, we have cement, sand, and gravel. I need to mix them all together to make some concrete. And concrete was found a long time ago by the Romans, actually. It's not a new construction tool. But to make concrete, we have to have the proper amount of cement, sand, and gravel. And the ratio is 1 cement to 2.5 sand to 3.7 gravel, little tiny rocks. All right, so they're going to give me a 200-pound bag of sand, and they want us to find out, well, how much cement and how much gravel do we need? And round it to the nearest hundredth of a pound. Okay, so let's take a look. So cement to sand, that's 1 to 2.5. I've got 200 pounds of sand, but I don't know how much cement. So I set up this ratio. Whenever you have ratios, the easiest way to undo them or unravel them is just cross multiply. So 2.5c equals 200. I divide by 2.5. And I get that the amount of cement I would need would be 80 pounds. All right, well, let's see. I know now cement is 80, and I know the ratio from cement to gravel is 3.7. So I set up a new ratio, G for gravel. Cross multiply, oh, that's nice. 1 times G is just G. And I've got 3.7 times 80. And 3.7 times 80 is 296 pounds. And so that's the amount of little tiny rocks that we need to mix together to make concrete. Question 2, we continue the ratio. I have the property tax on one house is 1,293. I've got another house that's 280,000, and I want to know what is its property tax because they are in the same ratio. So again, simply cross multiply. 120,000x equals 1293 times that number. Divide by 120,000. And just to make life easier, I'm just canceling some of these zeros. And so what else? Let's see, 4 goes into 12 3 times. 4 goes into 28 7 times. So that makes this a bit easier to do. So I'm going to take 1293 times 7 and then divide that result by 3. All right, question 3. In question 3, I have the ratio of men to women in a math class is supposed to be 1 to 5. So I've got that. Men to women is 1 to 5. But I know more. If I know that in the class there are 210 students, well, some of them are men and some of them are women. Well, if I know men, then the amount of women in there will simply be 210 minus the number of men. Okay, so I'm going to put that up here with men and women. So if I simply cross multiply, I've got 210 minus m is 5m. Move the m so I get 6m equals 210, and then simply divide by 6, and I get the number of men would be 35. If I want to find the number of women, I would simply take 210 minus the number of men in the class. Let's see, question 4, similar kind of question. We have a chemist is going to mix water and alcohol together, and the ratio for water to alcohol is 2 to 6. But the container has 780 liters in it. So in this 780 liters, there's some water and there's some alcohol. And if I know the water, then the amount of alcohol in there is simply 780 minus that number. All right, so I'm going to put that back up here. Water and alcohol. Cross multiply. Okay, so I've got 2 times 780 minus W. Distribute in the 2. And so I get 1560 minus 2W is 6W. Move this minus 2W over. I get 8W is that amount. And so divide by 8, and I get that the water is 195 liters. And then I got this number for alcohol. Well, how did I get it? Well, I simply took the full amount, 780, minus the number that we got for the water, and that's how we got the 585 liters. And if I add these two numbers up, I should get 780. If I don't, then something went wrong. Question 5, we are looking at similar triangles. As soon as you see the word similar, you know that their sides are proportional to each other. All right, so what do they want me to do? They want me to find missing pieces. Let's see, I've got a 9 there. Don't know that, don't know that. I do know this, I know that, but I don't know A. Okay, well, let's see. Y over 9, got that. And the corresponding piece would be 11.25 over 6.75. And so I can cross multiply and I can solve that, and I can find out that y is 15. Okay, so I got that. What else? Oh, well, let's see. I know 15, I know 9. Here's x. I've got the Pythagorean theorem, which says x squared plus 9 squared equals y squared. Well, that's 15 squared. Here again, just in case you missed it, what I'm using is the Pythagorean theorem, which is true for all right triangles. And that is the sum of the squares of the lengths of the two sides must equal to the hypotenuse squared. All right, so let's see. 15 squared minus 9 squared is 144. And I get x is plus or minus the square root of 144. How did I get that? Well, this is the square root property, and so I can do that, and I get x equals plus or minus 12. But since this is an application problem, the minus has no meaning in this particular case, and so I get x is 12. Are we missing anything? All right, so x, what was x? 12. Okay, let me put that in. X is 12. What about a? Well, there are a couple of ways I can get a. I can use the Pythagorean theorem on this part, or I could set up a ratio between 12 over 9 would have to be a over 6.75. Either way will work. Let's see, I think I used the Pythagorean theorem and found out that a was equal to 9. So whichever you find easier, using the Pythagorean theorem or set up a ratio. And that concludes section 4.4.